Hello everyone, let's start about unit number 1 multi-stage transistor amplifier. Let's revise first as we discuss about the introduction to multi-stage transistor amplifier. Then we discuss about the raw important terms related with this. The important terms are gain, then frequency response, then gain in dB, etc. Then we discuss about the role of capacitors. There will be basically three capacitors are used in this: input capacitor, coupling capacitor, and bypass capacitors. Let's start about the next topic. The next topic is types of multi-stage amplifier. We know very well there are basically three types are there according to the coupling use. The first is RC coupled transistor amplifier, transformer coupled amplifier, and direct coupled amplifier. Let's start with the first one, that is RC coupled transistor amplifier. As name itself indicates, RC, that RC means resistor and capacitor. So we can call that by coupling a two-stage. By coupling a two-stage, we are using resistors and capacitors. It is one of the most popular coupling because it is very cheap and provides an excellent audio fidelity. Audio fidelity means our audio range, that is 20 Hz to 20 kHz, it provides a better frequency response. It is usually employed for the voltage amplification. It is generally used for the voltage amplification. Why it is? Let's first discuss about the figure, the circuit diagram. See, circuit consists of two stages. Whenever you couple between two stages, a stage means first transistor, second stage means second transistor. See the collector terminal of the first stage and the base terminal of the second stage. We are using a coupling between two stages. The coupling between two stages will be provided by using capacitor, and along with this there will be about two biasing resistors are used, that is R1 and R2. To couple between two stages, a coupling capacitor R1, coupling capacitor and R1 and R2 will be used. That's why it is named as a RC coupled amplifier. Let's see about the construction. It is used of CC to connect the output of the first stage to the base of the second stage, and for the next stage similarly a CC or coupling capacitors are used. As a coupling from one stage to next stage is achieved by using coupling capacitor and resistors R1 and R2, therefore it is called as a resistors capacitance coupled amplifier. So see, the output of the first stage is coupled with the input to the next stage by using capacitor and resistance. That's why it is called as a RC coupled amplifiers. So it consists of resistance R1, R2 and RE, where R1 and R2 are used for the biasing and RE is used for the stabilization. That's why we can call that the R1, R2 and RE are used for the biasing and stabilization. And the bypass capacitor, that is CE, a bypass capacitor, that is CE, that is offers, it is used in the parallel with the RE to offer the low reactance part to our signal, that is AC. That's why we are using R1, R2 and RE and CE. Without this, if we are not using R1, R2 or CE, what happened? The gain will be lost. Then we are using CC, that is called as a coupling capacitor. That is, we know very well the working of capacitor. The working of capacitor will be like that way. It is block DC and allow AC to pass through it. Therefore, it provides the best DC isolation between two stages. If you want to couple between two stages, we are using coupling capacitor to provide a DC isolation. Next, working of this. We know very well, as the transistors working, whenever you feed input to base of the first transistor, it appears amplified across the load resistance, or we can get a collector resistance RC. The amplified signals will appear across the RC and it will be given to the next stage, that is base of the next stage, by using coupling capacitor CC, and again that gain will be further amplified by the second stage. So and so on. This way, that it means the output of the first stage is fed to the next stage, and so on. That is called as a cascading construction. Why it is connected like that way? The output of the first stage is coupled with the next stage, so we can tell that the overall gain will be increased. But it may be mentioned that the total gain means the output voltage ratio of the output voltage to the input voltage, it is always less than the product of the gain of the individual stages because of the loading effect. Because we know very well the second stage is made to follow the first stage, and so on. The effective load resistance of the first stage is reduced due to we are using a input resistance of the second stage, and so on. This is will be again the reduce the gain of the stage which is loaded by the next stage. For the third stage, if you are using a 3 stages RC coupled amplifier, then third stage does not have any kind of first and second stage. Because of that, it will be have a no loading effect. So we can call that the gain of the third stage which has no loading effect and it remains unchanged. In the next lecture, we will learn about the frequency response. Thank you.